For part D of this FRQ, the question is, given that f of 1 equals 3, write an expression for f of x that involves an integral and find f of negative 2 and f of 4. Now, for part B, we're going to apply our knowledge of the net change theorem that the integral of a rate is the net change. So, we're going to have to work around the only thing that we know that for certain in this situation, which is that f of 1 equals 3. So, as you'll notice in the integral, the lower bound isn't 0, it's actually 1. And the reason for this is we don't know what f of 0 is, so we can't account for the initial condition of f of 0, but we can for f of 1. So, we're going to have the integral from 1 to x, and x is there instead of a number because this is supposed to be a generic expression for f of x as an integral of f prime. So, the integral from 1 to x of f prime of x dx will account for the net change from x equals 1. But we're still not done yet because we have to account for what f of 1 is. And to account for that, we're just going to add 3. So our expression is going to be 3 plus the integral from 1 to x of f prime of x dx. And if you're not sure about this answer, there's actually a way to check it using the fundamental theorem of calculus. So if we try to solve this expression, we get 3 plus, and then we're going to FTC this integral. And we know the antiderivative of f prime of x is just f of x. So 3 plus f of x, with x as the variable, is just f of x minus f of 1. So 3 plus f of x minus f of 1 is equal to 3 plus f of x minus 3, because we know that f of 1 equals 3, and that leaves just f of x. So f of x equals f of x, this expression is true. It's the correct answer. Now to find f of negative 2, we simply plug in negative 2 to our... we simply plug in negative 2 in our integral. So f of negative 2 is equal to 3 plus the integral from 1 to negative 2 of f prime of x dx. And as you'll notice, our upper bound is actually lower than our lower bound, so we're going to have to use the fundamental theorem of calculus on this one too. And we're going to change the expression to 3 minus, we're just going to flip the sign, of the integral from negative 2 to 1 of f prime of x dx. And this is extremely easy. The information is actually given to us. The area underneath the curve from negative 2 to 1 is 9. So the only thing we have to be careful about here is that we're left with 3 minus, and we're not plugging in 9, we're plugging in negative 9, because we need to work with the signed area underneath the curve, which is negative because this area of the curve is underneath underneath the x-axis. So we're going to have 3 minus negative 9 equals 12. So f of negative 2 equals 12. And we're going to repeat that process for f of 4 to get f of 4 equals 3 plus the integral from 1 to 4 of f prime of x dx. We don't have to change anything here, we're just going to solve it. And once again, it's given to us that the area underneath the curve from 1 to 4 is 12. And once again, we're going to have to flip the sign because it's signed area and it's underneath the x-axis. So we're going to be left with 3 minus 12 equals negative 9. So f of 4 equals negative 9.